MCPs are great, but as we add more and more MCP servers, we realize that they're eating the context window, even before our first prompt. The problem compounds when we are building agents that will potentially have access to thousands of tools. Anthropic just shipped 3 features that fix this problem. Let me show you how they work. Hey, Alex here from GritAI Studio. MCP is a really powerful way to expand the context of our AI agents and to equip them with more tools. Connect Claude to GitHub, Slack, your databases, file systems, whatever you need. But there's been this scaling problem. The more tools you connect, the more context we fill, even before our first prompt. Not only does it bloat context, we end up with wrong tool selection and slower responses and so on. Anthropic just published their solution. 3 beta features they've been using internally, and they shared the benchmarks. This is actually really cool stuff. Now, first things first. When Anthropic started talking about this conceptually a few weeks ago, a lot of people shouted that MCP is dead and this was the wrong approach and so on. And I completely disagree, and so does Anthropic. This is not about MCP being the wrong approach. It's about how we front-end loaded all tool definitions into context, and that approach has proven to not be scalable, at least in many cases. So stop saying that this kills MCP or whatnot. Let me show you the numbers from their article. A pretty normal 5-server setup. That's 58 tools consuming more than 55,000 tokens before Claude even reads your first message. You can add in Jira another 17k tokens, and you're approaching 100,000 tokens overhead. Anthropic mentions internally they've seen tool definitions hit 134,000 tokens before optimization. But token cost isn't the only problem. The most common failures are wrong tool selection and incorrect parameters, especially when tools have similar names like notification send user versus notification send channel. So they built these 3 features to fix this. Let me walk you through each one. First, the tool search tool. The main change that they proposed and introduced is a tool search tool that discovers tools on demand. Instead of loading every tool definition upfront, you tag them with the for loading equals true, and then Claude only sees a lightweight search tool of around 500 tokens, plus any tools you've marked as always loaded for the most common tasks. When Claude needs a capability, it searches, loads just that definition, uses it, and moves on. Progressive disclosure, just like we saw with the introduction of skills in Claude. We did a whole video on skills over here. So with the traditional approach, all your MCP tools are loaded upfront. Let's say 70,000 tokens for 50 or so tools. With the new tool search tool, we only load the tool itself plus 3 to 5 most relevant tools that we use. About 8,700 tokens in total. That's an 85% reduction in token usage while maintaining full access to your entire tool library. You have to admit, that's simple, yet absolutely brilliant. For MCP servers, you can defer entire servers while keeping specific high-use tools loaded at all times. And here's the benchmark that matters. Opus 4 improved from 49% to 74% accuracy on MCP evaluations. And Opus 4.5 went from 79.5% to 88.1%. That's a significant jump from just smarter tool loading. One more thing, this doesn't break prompt catching. Deferred tools are excluded from the initial prompt entirely, so your system prompt and core tools stay cacheable. Okay, the second feature, Programmatic Tool Calling. Traditional tool calling has 2 problems. First, context pollution. When Claude processes a big dataset, the entire thing enters context, even if it only needs a summary. Second, inference overhead. Each tool call requires a full model pass. The solution introduced by Anthropic let Claude write Python code that orchestrates multiple tool calls. Intermediate results stay in a sandbox code execution environment, and only the final output comes back to Claude's context. Pretty clever. So here's their example. The task is which team members exceeded their Q3 travel budget. So you have 3 tools: get team members, get expenses, and get budget by level. With a traditional approach, we would fetch 20 members, call get expenses 20 times, each returning 50 to 100 line items, and that's more than 2,000 expense records, really just flooding Claude's context. Then Claude manually sums and compares. But with programmatic tool calling, Claude writes a Python script. The 2,000 expense line items, they never enter Claude's context, just the final answer: 2 people which exceeded their budget. You simply add the code execution tool and then set allowed callers to opt-in tools for programmatic execution. The API will then convert these tool definitions into Python functions that Claude can call. According to their benchmarks, the average token usage dropped from 43,000 to 27,000. That's a 37% reduction on complex research tasks. This is what Claude for Excel uses to handle spreadsheets with thousands of rows without overloading the context window. It's really simple, yet really clever. Okay, the third feature, tool use examples. JSON schemas define what's structurally valid, but they can't express usage patterns. When should you include optional parameters? What format should dates use? What's the ID convention? Consider this create ticket tool. The schema says due date is a string, but should Claude use 2024-11-06 or November 6, 2024, or a full ISO timestamp? Is the reporter ID a UUID, or is it just 1, 2, 3, 4, 5? Tool use examples let you provide sample tool calls directly in your tool definitions. From 3 examples, Claude can learn that dates use this format, IDs follows this format, critical bugs gets full escalation, feature requests get partial information, internal tasks can be minimal. The result? Accuracy on complex parameter handling jumped from 72 to 90%. That's the difference between an agent that kind of works and one that you can actually deploy. Here's the key insight. These features are complementary. You layer them based on your bottlenecks. Context bloat from definitions, use the tool search tool. Large intermediate results, make use of the programmatic tool calling. Parameter errors, tool use examples. A complex agent might use all 3 of them. Search discovers tools, examples ensure correct invocation, programmatic calling handles orchestration. Each solves a different problem. So when do you actually need this? For the tool search tool, more than 10 tools available or tool definitions that are more than 10,000 tokens. If you're experiencing selection accuracy issues, and maybe when you're building MCP systems with multiple servers. For the programmatic tool calling, when you're processing large datasets where you only need summaries, or when you do multi-step workflows with 3 or more dependent calls, filtering or transforming results before Claude sees them, and parallel operations across many items. Use the tool use examples when you deal with complex nested structures, tools with many optional parameters, or domain-specific conventions. Similar tools where examples clarify which one to use. Start simple and then add these when you hit the scaling problems that they solve. As agents tackle more complex workflows spanning dozens of tools and large datasets, dynamic discovery, efficient execution, and reliable invocation becomes foundational. Remember that clear descriptive definitions improve discovery accuracy. And you should also add system prompt guidance so that Claude knows what's available. As a rule of thumb, Anthropic recommends that you keep your 3 to 5 most used tools always loaded, and then defer the rest. This balances immediate access for common operations with on-demand discovery for everything else. These 3 features move tool use from simple function calling towards intelligent orchestration. If you're building agents with MCPs, this is the path forward. These 3 features are available in beta. To enable them, just add the beta header and include the tools that you need. I'll link the article and the docs in the description below. Thanks a lot for watching. I hope you found this video helpful. Feel free to like and subscribe for more videos like this one. And I'll see you in the next one.